know what? I may have forgot to start the last one. That's okay. We'll just watch it here a little bit. You got to be processing all these, don't you? But I don't need to watch them all. It's just see what happens. So that little tube was empty, and then we put the powder into the tube,
That's
right?
Mm-hmm.
And now we're picking, now this large
In order
tube.
to dispense the water.
Yeah, now what's the reason for the size of that thing? Why couldn't we just put it directly into the...
That's well, some of that is my point. I think a lot of it is possibly unneeded. I mean, if you can reduce some steps, I mean, I don't know why that was done.
Let me ask you, is there some reaction that takes place if you put the powder, pre-fill the powder already in those little glass vials?
You have to take the weight, the tear weight.
Yeah, you have to take the
Oh, you gotta wait.
because we're getting a weight.
Okay, so you gotta wait a vessel. Wait a minute, you gotta wait a vessel before you put the powder and then after?
Yeah, we do a tear on the vessel, and then we weigh the vessel with before we actually add the water. So that's why we don't, because that vessel has to be teared first.
I want to show you something we did for PepsiCo.
Okay.
It's a little different type of process on your...
Okay.
Now, what does the centrifuge do?
The centrifuge, so what happens is the pores that are left, the water that's left on the pores, we get a weight from that, and then it does a calculation, and that whatever that's left on there, that gives us the pore volume. So the purpose of the centrifuge is basically to get rid of, to precipitate any water out that doesn't really belong there.
The water's going to go
porous.
through, it's going through the filter
That's
down the bottom, right?
Yep.
Could you put that in a vacuum nest? Would that do the same?
Say that again?
Vacuum nest. Suppose you put it in, instead of centrifuging it, we put those things into a vacuum, close the vacuum, pull a vacuum on it. That'll pull all the water out. You set the vacuum level and the length of time that you want it to pull.
That's actually probably a great idea. I would think that it would probably have to be calibrated to what we have now. I mean, of course.
Well, we'd have to, I mean, you'd have to, there's probably a little bit of empirical testing you'd want to do, which means we may want to come and find out, for example, how, at what setting on the vacuum, how much vacuum do you need, and for how long do you need to get the
that's
process
a
where
great
you want
idea.
it.
It's a great idea.
I want to talk to you about a couple things here, okay?
And Dory, I also want to set it up for the ABD, if we can.
Okay, so you're measuring the vessel with the powder in there.
Yes.
But the powder is pre-dispensed into the vessel, right?
Yes.
Okay, then you're going to take that vessel and put it over here, and you're going to add another powder, right?
Yes.
Compound, I guess, I'm not sure.
It's catalyst, actually.
A catalyst, okay, so you're going to add a
Fluid
catalyst.
cracking catalyst is what we call it.
A fluid tracking?
Cracking.
A fluid cracking.
They use it in the refinery industry.
You gotta forgive me, it's not my profession, so I don't understand all the acronyms, lingos, and all that, you know. they're going to weigh that so they know how much of the catalyst they put in.
That's right.
Okay.
So that's why we needed to put a tare weight on the
Yeah.
empty
Yeah.
valve.
The empty vial with the initial compound in there, right?
Right.
So that's going to go back in here. Take that little guy off. It's like alignment tube, really.
That's all it really is.
Yeah. It's probably chamfered, so it lines it right up, right?
Right.
Okay, so now is that a measured volume?
Yes.
How do you measure the
Here's,
volume?
you can see it here. Here's the register.
Excuse me a second. Well, let me. He's going to come all the way around. I'm surprised. Okay. So. All right. Now he's going to go get the other one out of there.
Yeah.
Now that other one has to be weighed.
It has to be weighed.
Just waiting for that to slow down. How much fluid's going in there?
Is it 10 cc's, Gordon?
I don't know.
I want to see it coming all the way down. Does it fill the whole?
It's probably in mLs. You're probably milliliters of volume. Yeah.
Maybe 10 milliliters, but I'll let you know in a second.
Steve was supposed to come in today, and he hasn't been in yet. It's been a week.
I thought it was Tuesday or Wednesday.
Kurt said Tuesday. He said hopefully Tuesday. He said that Friday.
Oh, okay.
But remember, we put the initial service call in like last Tuesday. It's been like a week.
Yeah, okay. I thought I saw something that said Tuesday or Wednesday. I saw an email that said Tuesday or Wednesday. And you, somebody out there, I think you go over there. Oh,
You got
yeah.
a, yeah,
I have an email.
you got an email and I sent it to you. I don't know. I was under the impression.
Now it took one of those tubes out, and then it put one in as being centrifuged now, and it's still waiting. What's going to happen to the tube it took out?
It's going to eventually take that out and it's going to weigh it over here.
So is there a reason for the long delay in doing
I
that?
don't know what's the reason for
It
that.
takes 15 minutes. It has to be in a centrifuge 15 minutes.
Well, it's
No,
not
no, but
the one side.
it brought one out of the centrifuge and it just parked it here.
That's probably a
Is that the weight?
balance.
Oh, that was a balance.
Oh, that's a balance.
Okay, that was a balance too.
Okay, yeah, because you're going to have to put,
But I didn't see it weigh the first one though. That was the thing.
I didn't see it either. But
see the syringes here.
Yeah,
And
yeah.
there's the DR water.
Okay, and you're using just you're just using a regular. That's
Yeah.
the pump, right?
It's just the pump.
Syringe. Oh, just a regular syringe pump there. Okay. Because we use a lot of Hamilton pumps. In fact, I'll show you a couple concepts. You know, I haven't thought this through, and I want our engineering folks to kind of think it through a little bit.
Sure.
But this will help them kind of get an idea of the layout.
Sure. I mean, because if it was up to me, I didn't know if this platform had to be this large.
I don't know that it needs to be either. It just depends upon. See, I think it's that large probably because of the numbers of samples
Yeah.
that you need to handle, and you've got all the labware. You've got,
You have a big centrifuge. You have a big robot, right?
yeah. See, you've got 2 sets of these to do 2 sets of those, and then you got to have 2 of the smaller trains because you're dumping the what do you call that buffer?
The FCC.
Splitting buffer.
What's that?
What's that buffer in there?
Catalyst.
Oh, catalyst. You call it a catalyst. Okay. Yeah. So in other words, you got 2, 4, 6 trays. So those where you start out.
You can do 70 samples in all.
What do you do with those trays? Now we have.
This is for this test. We're going to show you.
Oh, it's a
that
different
after this
test.
is finished.
Okay. All right. All right. So let me just stop this here. I wonder if I can restart it.